It is another ordinary quiet winter day. A person walks down the street, his steps hushed by freshly fallen snow. The air is chilly and a stillness envelopes the surroundings, occasionally disrupted by the gentle rustling of the wind through the bare trees. Several eyes perch on lampposts and on building facades, follow the walker's every gesture, from the tilt of their head to the rhythm of their stride. The eyes then look inwards and tirelessly search its memory for a vast repository of patterns of cadence, strides, gestures, and postures. The surveillance cameras attempt to match the captured gait with any known records of interest. It is a subtle dance between human curiosity and the tireless efficiency of artificial intelligence, all unfolding in the background of what is just another ordinary, quiet winter day. It may feel dystopian or Orwellian to consider that such a scene could exist today, where surveillance cameras use recognition technology to examine and analyze your every move. However, this sort of technology currently exists in CCTV street cameras in several parts of the world. In 2018 in India, Karnataka police identified an individual who murdered journalist Gauri Lankesh by examining and matching the walking pattern of the killers as captured in the CCTV footage at the time of the murder to potential suspects. Meanwhile, in the UAE's Dubai, law enforcement have indicated that gait recognition technology, which was employed in use since 2016, have assisted in more than 3,000 arrests in 2018. It is also in China. Police on the streets of Beijing, Shanghai, and Chongqing are using gait recognition technology to identify suspects from the shape and movement of their silhouette. Gait recognition groups spatial temporal parameters of a person's stride and is based on the idea that an individual has a distinctive way of walking, which can be understood from a biomechanic viewpoint. Gait recognition technology is a form of behavioral biometric technology. Behavioral biometrics refers to the study of human behavior patterns, particularly as they relate to distinguishing one person from another through verification or identification methods, and to predict someone's behavior or intentions. Not only can existing behavioral biometric technology verify and identify who we are based on the way we walk, but it can also include the way we swipe on a touchscreen, type on a keyboard, or move a mouse. The focus on authenticating or identifying behavioral patterns rather than the physical characteristics of an individual is useful in situations where traditional biometric methods are not feasible, such as remote authentication or continuous monitoring of user activity. The analysis of behavioral biometrics involves collecting and analyzing data over time to establish a unique baseline of behavior for a particular individual that can be used to identify or authenticate the individual. This is known as behavioral biometric profiling. Conceptually, behavioral biometric profiling promises services that are characteristics of an evolved society. For instance, there is current research and development dedicated to the analysis of drivers' behaviors, such as drivers' steering patterns and acceleration or deceleration habits, to detect changes that may indicate driver fatigue. There is also current research on how behavioral biometric technologies can be integrated into smart monitoring systems in assisted living environments to evaluate and even predict the emotional and cognitive status of individuals. Furthermore, the September 11th attacks and the subsequent war on terror have fueled the desire for categorizing and profiling people. As mentioned previously, behavioral biometric technology is used for law enforcement purposes through gait recognition surveillance. This work would be extended to various real-time applications to recognize the various human behaviors that can be criminal, such as terrorist behaviors, currency theft, criminal street activity, students' behavior on campus, behavior in public transportations, and so forth. Also, with frequent fraud and cybercrime, banks have begun to employ the use of of behavioral biometric technologies like voice recognition authentication to combat online fraudsters. However, there is concern that the rise and empowerment of behavioral biometric technologies amongst power holders and policymakers can result in Orwellian Big Brother scenarios that threaten privacy, due process, and increase social bias. Behavioral biometric classifications follow predefined models or pre-selected sets of samples that are classified into subgroups. Ultimately, human beings are reduced to being coded bodies, where our physical movements may be granted or restricted based on prior determinations. This can lead to individuals being classified into arbitrary subclasses such as gender, age, economic or sociological status, along with analysis of potential dangerous behavior. A consequence of being a coded body is the social stigmatization of an individual, whereby the individual is labeled automatically or has the potential to be a criminal or someone who is untrustworthy or unreliable. Thus, the surveillance involved in this type of classification is a form of social sorting. Social sorting emphasizes and reinforces differences and existing inequalities through the categorization of persons and groups into socioeconomic niches. Products of social sorting can include isolation, segregation, and marginalization. According to Ruha Benjamin, a sociologist and professor in the Department of African American Studies at Princeton University, computer systems' data sets, or the raw constituents of their machine learning, are riddled with the racial, economic, and gender biases of their programmers, and therefore their predictions, recommendations, and solutions can facilitate existing cultural prejudices and hierarchies. Sociologist David Lyon, internationally known for his work in surveillance studies, insinuates that social sorting through surveillance is a modern threat to freedom. The categories involved in social sorting rarely are questioned regarding its ethics, despite social sorting's consequences for opportunities and freedom to make choices. Take, for instance, the Chinese government's social credit system, which links public and private data on financial and social behavior to determine behavior of individuals and organizations, and punish or reward them according to certain agreed upon standards of what is considered appropriate conduct. It has been argued that the scale and potential impact of the social credit system can cause serious impacts to individuals and organizations that could result in the opposite of its promised effects. Now, consider the following example of how social sorting works through behavioral biometrics. People with disabilities may have distinct behavioral patterns due to their condition that can deviate from what is considered normal in society. Therefore, individuals with tremors or involuntary movements may have a unique mouse movement pattern that could be flagged as suspicious, leading to denied access to certain services or products. Furthermore, the increasing accessibility of behavioral biometric technologies has ushered in an era of what sociologist Ifeoma Anjuana terms as limitless worker surveillance. For instance, it has been reported that some organizations use webcams to track worker attentiveness. These web cameras collect and evaluate behavioral biometric data such as eye movements, body shifts, and facial expressions to determine whether employees are paying attention during video calls and during their work tasks. Employees who are deemed inattentive can be reprimanded. What is more, these proctoring applications are more likely to misidentify people of color, particularly women of color, than their white male counterparts. Notably, independent research firm Vanson Bourne reported that organizations who monitor or plan to monitor workers are reporting drastically increased attrition. This increased attrition amongst workers can be explained by the impacts that constant surveillance has on mental health. A sense of perpetual lack of privacy threatens a person's sense of security, and such can heighten stress, fatigue, and even paranoia. Furthermore, according to Jonathan Penny of Oxford University, the existence of widespread surveillance can result in self-censorship, which can foster fear and conformity so that we refrain from taking risks. Widespread surveillance fueled by behavioral biometrics ultimately becomes a part of nature itself, where it is a state that we as human beings are constantly plugged in, a state in which we cannot limit. Considering the arguable dystopian-like impacts that behavioral biometric surveillance technology can pose, we must look to next-generation biometrics that is driven by privacy and ethical considerations.